Hello viewers, in this session we are going to discuss this important and conceptual definite integral. So we have to evaluate this definite integral. The limits are from minus pi by 4 to pi by 4 and the integrand is mod of cosine x, right? So let us call this integral as I, and here we are going to make use of the concept of sign convention of cosine function in four quadrants, right? And moreover, we'll also make use of the definition of modulus function. So let us now first consider the sign convention of cosine function in the four quadrants. So here we have the four quadrants. Here we have 0, here we have pi by 2, here we have pi, then we have 3 pi by 2, and here we have 2 pi. Right now we know that the cosine function is positive in the first and fourth quadrant, and it is negative in the second and third quadrant. So here we have the first quadrant, here we have second, third, and fourth. So cosine function is positive in the first and fourth quadrant, and it is negative in the second and in the third quadrant. So now here the limits of integration vary from minus pi by 4 to pi by 4, right? Now see here we can take say O, and here we can take the point A. So taking these 2 points, that is O and A, and let us consider this ray as the initial site, right? And when we rotate this initial site in anti-clockwise direction, and we form an angle of say pi by 4 like this. Suppose this is our angle pi by 4, right? So here we take the angle as positive pi by 4, because when we measure an angle in anti-clockwise direction, then the angle is taken as a positive, right? So here OA may be taken as the initial side, and when we rotate this initial side in anti-clockwise direction, and here we form the ray say OB, then this angle is taken as positive, right? So here we have plus 45 degrees, and when we rotate this ray OA, which is taken as initial side, in clockwise direction, that is like this, and we form an angle say pi by 4, then this angle is taken as negative pi by 4, that is minus 45 degrees, right? So this side, that is OB, is known as terminal side, and similarly the side here we can take C. So OC is also the terminal side, right? So here we are dealing with the concept of measuring an angle in the anti-clockwise direction and in the clockwise direction. So if we take OA as the initial side, and if we rotate it in anti-clockwise direction, and we form an angle of 45 degrees, then we take this angle as positive pi by 4 or positive 45 degrees. And when we rotate this initial side OA in clockwise direction, and we form an angle of say 45 degrees, then here the sign of this angle is taken as negative pi by 4 or negative 45 degrees, right? So now let us consider the definition of mod function. Now see, mod of p is defined as positive p when p is greater than or equal to 0, and negative p when p is less than 0. And here we have a mod of cosine x. So mod of cosine x can be defined with the help of this definition. So we can now write here positive cosine x when cosine x is greater than or equal to 0. And we have just discussed that cosine x is positive in the first and fourth quadrant, right? That is when x belongs to uh, either the first quadrant or the fourth quadrant, and mod of cosine x is equal to negative cosine x when cosine x is less than 0, and cosine x is less than 0, that is cosine x is negative when x belongs to the second or the third quadrant. So here x belongs to either the third quadrant or the second quadrant. So here we write second quadrant and here we write the third quadrant. So now we have to integrate from minus pi by 4 to pi by 4. Now see, when we go from minus pi by 4 to pi by 4, it implies that we are making a transition from fourth quadrant to the first quadrant, and in the fourth quadrant and in the first quadrant cosine function is positive, right? So when we have to integrate from minus pi by 4 to pi by 4, that is we have to integrate like this. That is we have to go from positive, that is the fourth quadrant in which cosine function is positive, to the first quadrant where cosine function is also positive. So it implies that when x belongs to the interval that is minus pi by 4 to pi by 4, then cosine x is positive, right? That is when we integrate from minus pi by 4 to positive pi by 4, then in both the quadrants cosine x is positive, right? So from the definition of mod function, we can now write mod of cosine x is equal to positive cosine x when cosine x is greater than or equal to 0, and cosine x is greater than or equal to 0 when x belongs to either the first quadrant or the fourth quadrant, right? So now here for mod cosine x, we can now write positive cosine x, and we have the integral I as minus pi by 4 to pi by 4, and here we have positive cosine x, and here we have dx. So now we have a simple integral here, and we know that the integral of cosine theta is equal to sine theta, right? So here we have simply sine x. The integral of cosine x is sine x, and limits of integration are from minus pi by 4 to pi by 4. So now let us substitute the limits and we'll take the difference. So we have first x is equal to pi by 4, and then we have x is equal to negative pi by 4. So here we have sine of minus pi by 4, and from trigonometry we know that sine of minus theta is equal to negative sine theta. So here we have sine pi by 4, and here we can take this negative sign outside due to this result. So here we have positive, and we have sine pi by 4. So sine pi by 4 plus sine pi by 4 is 2 times sine pi by 4, and we know that sine pi by 4 is 1 over square root of 2. So we have 2 over square root of 2. Now we can rationalize here. So we have 2 over root 2 times root 2 over root 2, rationalizing the denominator here. So we have 2 root 2, and here root 2 times root 2 is 2, and 2 get cancelled, and we have square root of 2. So the value of this integral is equal to square root of 2. So viewers, this is how we can easily evaluate this definite integral using these two concepts, that is the sign convention of cosine function in the four quadrants and the definition of mod function. But here we can also evaluate this integral using the properties of definite integrals. That is, we can make use of this property, that is minus a to a, and here we have f of x and dx. And from the properties of definite integrals, we know that this integral is equal to 2 times the integral 0 to a f of x dx, provided this function f of x is an even function, that is f of minus x is equal to f of x, right? So we can first make use of this property to this integral, and then subsequently we can make use of the definition of mod function.